Yeah, I think it's here. Yeah, that's the screen we have here. And yeah, remember that's the commands we have in our last session. Let me just show you my screen. Okay, so this is the screen I have here. So what we are going to do is to build up some connection with our GitHub account, because we're gonna save our files to our GitHub account. So if you want to do that, we have to do something. Actually, there are 2 or 3 ways to do that, but in this lecture, I'm gonna just I'm gonna show you one approach only. I think I'm not sure if it's the best approach or not, but I think it's just an option for you to choose. So for this course, let me just log into my GitHub account here. Okay. Okay, now I'm in my GitHub account. So in your case, you probably will have an empty repository here, because you've seen here I have created a lot of repository. So in this case, let me just create a new repository. Okay, so I'm gonna create a new repository, and for this case, we have summer. That'll be a lot easier for me. Okay, so I'm trying to create a new repository. That means everything I saved on the cloud in AWS can be saved in this repository too. Okay. So you can just yeah, you can add some description or not. It's up to you. And public or private, but for this case, we only I just leave it as a default. We don't have to change anything here. So let me just create a repository. Okay. Can you see my screen here? Okay. So now you have create a repository in GitHub, and we got some information here. We got the link. So this link is important. We need to use this link later. So just leave it here. Yeah, you can also have some yeah, you can write some explanation or comments in your README file, but you can do it later. Yeah, but now we have a link here, and then we go back to our studio. Okay. So usually when we try to pick up our file, we usually use project. So in this case, I will open a new project here. So let's go to the file, and I'm gonna create a new project here. Okay. Yeah, I don't have to save here. Okay, don't save. Okay, so yeah, you can use new directory or use version control. But since we have created a directory, a repository on the GitHub, so that we can just use version control, and we use Git. Okay, Git is clone a project from a Git repository. Okay, just click it, and then we can just paste the URL from the GitHub, so that we go back to the GitHub, and then we can press here, and we copy the URL here. And project directory name, you can create a project name. So for example, summer. Okay. Summer. Whatever, yeah, I don't know. But you just create a project here. Okay, so let's create a project. Okay. Okay, so now you can see we have created a project called FinTech Summer, and there are two files being automatically generated. We call it Git Ignore and the FinTech Summer, our project. Yeah. Okay, so let's create a new file here. Okay, so you can write anything you like here. For example, like let's save the file. This is a test file. Okay. So let's save it. Let's save it. It's a file. Okay, now we got the test.r. Okay. And when you create a project linking to GitHub, probably you will notice down below here there's a git command shown up here, so you can just click git. Okay. Okay, when you click git, you can see 3 files here, but usually you can just check the newly created file we call test.r, and then we can just back up the file to our GitHub. Okay. Okay, so if we want to back up the file to GitHub, probably we have to go through two processes. Okay, the first one is to click the file we want to back up, and then we have to press the command here. Okay, so we need to press commit. Sorry, we have to press the commit button. Okay, when you press the commit button, we'll see the commit message. Then we have to type anything we like, but don't leave it blank. You have to put something there. So let's say 0723. or sometimes this is my first commit. Okay, so let's commit the file here. Okay, so because this is your first time to commit the file to GitHub, you will get this message here. So it asks you to run these 2 lines of command. So first of all, you have to run this, okay? And this, you can just copy this line, okay? Of course, you have to change the email to your email in the GitHub account, okay? And then, so let's just copy this one. Just a minute. Let's just go to the terminal, right? We need to go to terminal to execute the command. And we have to paste it. Change the mailbox to your email box. So that's my email box here. Okay. So I need to change and then press enter. Okay. Then we need to okay, so we need to copy the second line of command and reset the username to your name. Paste it here and reset it to your name here. Okay. So what else we need to do? Okay, I think it's done here. Okay, then we can try again. Just a minute. Okay, let me try again here. Okay, so I'll try to commit the file again, then it will show this. That means it's been created. The commit file, and I close this box. And then I have to run push. Okay, so remember when you try to back up to the GitHub, you have to run commit first and then push. Okay, you have to complete these 2 steps. So let me just push my file. So it will ask you to key in your username on the GitHub and the password. Okay, so when you see this message, that means you have completed the backup. Okay, so let's close this window and then go back to our GitHub to check if the new file is there or not. So let me refresh the web. Okay, so now you can see the test R has been created in the GitHub. So let's click here. You can see this is my comment. Okay. Okay, so that's done here. So in the future, whenever you wanna back up your file, you can just do the process here. So for example, like a equals to 2. So for example, let me just create a new command. Uh, so now, if you are going to save the file, okay, you can save the file right here. Okay, so if you save the file again, you're gonna see the Git here. You go to the Git screen, you will see a new item has been created, uh, but it's marked as modify. Okay, that means you have just modified your file test R, and you will show modify. Okay, so if you want to back up your file again, you can just repeat the process. Okay, so any problem about this? Any problem about this? Okay, so if you don't have any problems, then we can go down to the next session. Yeah, that would be the standard case, because when you try to create your own repo, you only have two files. So you can try to create a new file. Okay, you can try to create a new file. Let me show you here. Okay, uh, I just want to test if the backup works. So I just created a file called test. So if you don't have the test file, you can just go to the file to create a new file here and create a new file. Okay, so for example, like you can create many files as you wish. Yeah. So for example, we're gonna show you some slides here. Let me just show you here. 对。Okay. Okay, so now we can just review the slides here about the tutorial programming. Mm. Okay, so now I'm gonna show you some very basic R codes on AWS. So here are the slides. You can just see some very basic function. For example, like let's start from the plot. Okay, so that's very basic, and I also include my codes on the GitHub, and then to say if you to save some time of typing, you can go to my GitHub and download the codes. You can just copy and paste. Yeah. Uh, Basically, you can also download all files in my GitHub, but it's not necessary because now we just focus on some pieces of programs. So you can just copy my files and paste it. And I will give you some examples about the iris. And this is bar chart, etc. Histogram, okay, and the scatter plot, and how to do some overlaying charts and some examples. But in the following, we'll also cover another program r01 underscore 4.r. Okay, so in this lecture, we're gonna cover these two pieces of program. And one last thing is about the Explorer, because I just uh, happened to find a very great package that has been developed in recent years. We call the Explorer uh, because this package can help us to save a lot of times in codings in data analysis. So I think that's important for you to understand this package. Okay, so based on Explorer, we are doing the exploratory data analysis. And there are three ways to use the package: interactive data exploration, and it can also generate automated report, and of course you can manually explore the data set. Okay, so I would like to put more emphasis on this package. Okay, so let's go back to the start. So let's just follow the slides here. Let's go to the okay, R01 underscore 3. Okay, so I'm gonna go through all the codes really quick. So if you have problems, you can just stop me anytime you like. Uh, so let's jump to my screen.造出来。好 Okay, sorry about that. Okay, so now you can see my screen here. Uh, that's the that's the code for R01_3, and you can see my codings here. So I'm gonna go through those codes, and if you don't understand any part of that, you can just pass. You can just stop me here. Okay, so let's from the start here. So basically, I'm gonna show you some bar chart. So usually when we start writing codes in R, we tend to move everything from our memory. So we tend to issue this command. We call this rm followed by list equals to ls bracket here. So that means we're gonna remove everything from our environment. Okay. So let me just yeah, okay. So that's the traditional format in RStudio. Okay, so you can see when I add four dashes at the end of the line, then this line will be treated as index. So you can see there's an index here. Okay, so this the index one. Okay, or the title one, which is bar chart. So that will make your codings to be more organized, but it's up to you. Okay, so but anyway, let's just run this. First of all, we need to load up the data set. So we have to call up the library data set, and then we're gonna use ng cars. That's a traditional car data set. Okay, I'm gonna show you what this is. Okay, so NT cars. Now you can see the slides about the NT cars. This is another famous data set in R. The data was extracted from 1974. Yeah, actually we've seen another data set, NT cars, for 2018 in our last session, right? So that's the most updated one, but this is the most original one. Uh, this the data is based on 1974 data, but anyway, most of data structure are very similar. But this data set is quite limited. We only have 32 observations on 11 variables. So you can see we have MPG, CYL cylinder, displacement horsepower, uh, DRAT, weight, Q second, VS, AM, gear, carb. Okay, we got a lot of information down here. So we're gonna use this data set and iris interchangeably during our session. Okay, so you have to be familiar with these two data set. So let's see what we have here. So let me share this screen again. So now we're gonna use the uh, NT cars. So based on the bar chart, we can just issue the bar chart, and then NT cars star. We follow by a dollar sign, and dollar sign means we are accessing specific columns by name. So basically, you can see the name of the any cars. Car names, NT cars. So you can extract the car names of NT cars, and you can see down below here we got many different car names. And if you want to access specific current data, you can just issue NT cars and dollar sign followed by we got some columns here in the pop-up window. So you can just choose cylinder and you can press, you can execute the line of code. You got the results here. Okay, so this is very basic. This is a very basic command here. Okay. Of course, we also have other commands like if we need to create a table. For example, we need to look into the frequencies for cylinder. So we can just use table function. Okay. And table actually can create a table like this. Okay. We got the uh, three different cylinders, which is 4, 6, and 8, and it will create the table for us based on the numbers of counts, and you can create cylinders here. Okay, and based on cylinder, you can just plot the. Okay, now you can see the plotting here. So it just shows some very basic plotting about the cylinder. Okay, and about this histogram, now we're gonna use iris. So we can just one useful function to check the data is about head function. Usually we can use head, okay, to check the first 6 rows of data in our data set, and well, the default value is 6. So you will see there are only 6 rows in our data set, and you can also check the last 6 rows in our data set. So that means you can use tail, okay. So it will show you the last digit rows of your data, okay. And if you want to plot the histogram, you can use histogram here, and the command is HRST and followed by a specific column. Okay, so let's try the first one. Okay, then you'll get a histogram of iris, $sample.length. Okay, and of course you can also plot the histogram by group. Okay. So now we can arrange many different figures, many different plottings in one figure. So we can set up the parameter. So that's the multiple figure. We have 3 rows and 1 columns. Okay, 3 rows and 1 column. So you can set up your parameter here, and then you can run the histogram. Okay. And when you try to plot the histogram, you can even specify specific uh, uh, classes. So for example, in this case, we are specifying species to be Setosa, okay, and we can also set up the limit of axis and the brakes and the main lab. Actually, you don't have to worry about all those things. Yeah, you can just use histogram. Yeah, it can help you to plot everything. So just like what we did here, you can just issue a histogram. But if you want to modify your output, you can just add those specifications. So let's see what we have here. So now we have this one. Because we want to create multiple figures, so the first figure will be smaller. So let's run the second one. Okay, so that's what we got here. We got three sub figures from top to the bottom: petal width for Setosa, petal width for versicola, and petal width for virginica. Okay, finally, when you finish the the plotting, you have to restore the graphic parameters. Okay, so well, other functions like scatter plot, you can just try by yourself. Okay, so I'm gonna make it faster. Okay, so that's the scatter plot for MPG and weight. So obviously you can see there's a negative relationship between weight and miles per gallon, right? Okay, so the if car has less weight, the car tends to be more fuel efficient in terms of MPG, right? Okay, and other functions, of course, if you want to add other functions, you can make your plot looking better. So let's try this. Okay, so for example, like MPG, you can add a title or label. Okay, X label, Y label, and the man, which is title of the figure, and also box. Yeah, this is about the box plot. Well, this parameter, this setup is about the margin. So if you really care about the margin, you can also set a parameter like this. So it's not very important right here. Okay. So that's about the distribution across uh, across five variables. We have sepal length, width, petal length, width, and species. Okay, so if you want to do some special plots, for example, like if you want to overlay plots, okay, then you can use you can issue two figure commands and you create overlaying plots. Okay, so for example, like this is a case for links. So I'm gonna skip this. I just want to show you the results. Okay, so we have a histogram of links and we can add some options. So right now you don't have to worry about the specific parameter specification. You can try any numbers you like. You definitely will learn how to do that when you try to write those codes by yourself. So you just know what the results will get based on the commands. Okay, we know histogram. Okay, now if we want to add a normal distribution, yeah, we can add the command we call the curve. Okay. Okay, just a minute. Okay. So we got a curve line here, and then we can add more thing. So for example, like this. Yeah, that's what we are gonna see if we issue more figure commands, for example, lines and rug, etc. Okay. Uh, Okay, so but this is not very this is very standard commands in R. Of course, in recent years we have more advanced plotting package. For example, like we have a ggplot2. So I will suggest you to learn ggplot2 package instead of this. You really don't have to spend too much time in these commands, but those commands for plotting is very basic, are very basic. So you will learn the basic concepts of plotting from the beginning. And if you want to learn more advanced plotting techniques, for example, like ggplot2, uh, I'll give you some examples later. But right here, right now, I think that's enough for you. Okay. So let's move on to the next codings. We have R underscore one, R01 underscore 4. Okay. Now we're gonna use more advanced uh, commands. Okay. So for example, like num, if we wanna do some data analysis, we can just okay. So let's remove everything from our. Okay. Let's remove everything from our environment here. Okay. Okay, so let's load up the data set again, and that's our data set iris. So now we have to do some data analysis. For example, like we can use summary to summarize the species and sample length and iris. So all sorts of information can be created by summary function only. So you can see we have summary for sample length, and there are some numbers or statistic numbers are generated. For example, like minimum value, first quartile value, median value, and the mean value, third quartile value, and the maximum value. Okay. Yeah, of course, if you want to use some other package to help us to do that, you can you definitely can do that. But first of all, let's just introduce one package we call psych. Actually, that's a package developed by psychologists, because in psychology maybe they need some specific statistics to do some calculation to measure to measure their data qualities or measure their data characteristics. So they need to create some function for this. Okay, so let's use pack. Uh, Before we start, let me just introduce this package, because like I mentioned last session, whenever we want to use package, we have to install the package first, and then we have to so for example, if you want to use psychology, uh, okay, so for example, if I want to use functions in psych package, first of all, I need to install package, and then I need to load out the package. Okay, but sometimes it will take you a lot of time to do that. So why not just combine these two together? So now we have a new package we call package management. Okay, So package management can help us to combine these two together. So we don't have to type so many commands. So first of all, you still need to install package, okay? Pacman. So let's just use pacman, load install package pacman first. Well, this is just a command to make sure if you have pacman or not. If not, it will install the package pacman. Okay, so since I have installed pacman already, so I only have to uh, use the payload here. Okay. Okay, so let me just modify this. Sorry. Maybe I can just keep the original one. Okay, now all I have to do is just to use p underscore load and psc. Okay, so that's all I have to do. Okay. If you haven't installed psych package psych before, you will install the package automatically and load up the package automatically. So that means you just combine these two commands together. Okay. So that can help you save some time in your commands. Okay. So let's see what else. Okay. So let's just move down to the build button here. Okay. So let's just do some data analysis. For example, let's see what we have here. Let's just describe. Now I'm gonna use the describe function, but the describe function is based on psych. Okay, so let's see what we have here. So when you see the results, you're gonna see we got variables, number of variables, and mean, standard, median, train, uh, MAD, minimum, max, range, skew, kurtosis, standard deviation, etc. So obviously, describe can provide us a more detailed statistic analysis about the data. Okay, so that's all we have for describe. Okay. So yeah, of course, we have other data sets. Yeah, we've done that before. So let me just skip. Okay. Okay, so sometimes we can use select uh, in our data just to filter some specific data from our data set. Okay, so this is the histogram for iris petal length less than 2. So this is a histogram for this. Okay, we can also use this, and also we can use multiple selectors uh, by using this. And we can create a second here. Okay, so that's the plotting and some basic data analysis functions. Uh, that's very easy. So now our next issue is about the Explore package. I think this package is more interesting because it is very convenient to do some data analysis. So you can save a lot of time in writing codes. So let's say let's just load up the Explorer first. Actually, this is extra command. Let's just load up Explorer. So if you haven't installed Explorer, you have to install Explorer first using pload. It probably will take some time, so you have to be patient, and when it's done, then you can use the foreign codes. So for me right here, I'm gonna use Explorer underscore TBL. Okay, TBL actually represent a table. That's another data. Uh, that's another data format in R. In we have many different data format in R. We have for example, like characters. We have vectors. We have numbers. Uh, we have integers, etc. But the most used one is about the data frame. So when we have a data set, like for example empty cars, the data are stored in data frame. So let me show you uh, the class here. Okay, so when I issue the class, okay, I wanna know what type of data it is. So it shows data frame, okay. But of course, sometimes the data set will be saved in vectors or matrix, okay. But now we have a new data format we call table, okay. But so basically, table is more flexible than data frame. Obviously, now a lot of people are using table format instead of data frame. Uh, yeah, because many new packages are developing new functions um, to accommodate for table dataset. So in the future, if you are gonna use R as your coding program, you have to know table data format. But right now, we don't have to worry about that. We just use the command. But now you don't have to worry about the TBL here. Yeah, we just try to explore what's inside our data set. Okay, so now you can see the plotting here. We got 11 variables, and there are 32 observations. Okay, so you can get a very quick overview of your data. And if you want to dig into your data set, you can use explore underscore all. So let's see what we have here. Just wait for a few seconds. Yeah, we have the plotting like this. Yeah, it will show you the distribution for each variable. Of course, NA is not the value or missing value. So it will also show you the percentage of missing value here. And for categorical data, or yeah, you can see the categorical data. You will see the horizontal bar to show you the percentage across different variables. Okay, we got the automatic uh, or manual transmission. Okay, we got the three types of gear, 3, 4, and 5. You can see the percentage across gears, and you can see the percentage of carburetors. Okay, for each type of carburetors. Okay, so that's a very quick overview of your data. I think that's useful. And suppose we want to explore uh, the proportion of cars with 3, 4, and 5 gears specifically. We can just issue explore followed by the data set and the gear. Okay, so let's run this. Yeah, it will show you a clear picture of the percentage across 3 gears. Okay. Okay, so maybe we can take a break here and you can try those commands by yourself, and we can come back a few minutes later. It's okay.